Hi all, a very good morning to one and all. I'm Nayanthara. Today I'll be discussing about some concepts of metals and non-metals. We all know that out of 118 elements discovered, 90 are metals. The rest are non-metals. Let's see what are metals. Metals are elements. They lose their valence electrons to form cations. Metals are elements. They lose their valence electrons to form cations. They form positively charged ions. Let's see. Lithium is a metal with atomic number 3 and electronic configuration 2, 1. Lithium loses its valence electron to form lithium plus ion, lithium cation, with an electronic configuration of 2. Okay. Lithium is a metal. Similarly, non-metals are elements. They accept electrons to form negatively charged ions or anions. Non-metals are elements. They accept electrons to form negatively charged ions or anions. Okay, so let's see. Chlorine belongs to the halogen group. Chlorine having an atomic number 17 with electronic configuration 287, which forms chloride ion, Cl minus ion with electronic configuration 288. Now it's stable because the outermost shell contains 8 electrons. It's inert in nature. It's stable actually. So chlorine is a non-metal which accepts electrons to form chloride ion. 288 will be the configuration. Now let's see the physical properties of metals and non-metals. Let's see the physical properties of metals and non-metals. So, these are the main physical properties of metals. Metals are mostly solids in room temperature. They are sonorous. They have high tensile strength. They are lustrous. They have a shining surface. They have high melting and boiling point. They are good conductors of heat and electricity. They are malleable and ductile. Malleable means they can be beaten into sheets, and ductile means they can be drawn into wires. The main physical properties of the metals are they have high melting and boiling point, they are good conductors of heat and electricity, they are malleable, they are ductile, they are solids at room temperature, they have high tensile strength, and they have high density, and they are good conductors of heat and electricity, and they are solids at room temperature. These all are the physical properties of metals. And what are the physical properties of non-metals? The non-metals have the properties just opposite to that of the metals, which means the non-metals are solids, liquids and gases at room temperature. They don't have much high tensile strength. They are not sonorous. They don't have a shining surface. They are bad conductors of heat and electricity. They are non-malleable. They are non-ductile. They have low melting point and boiling point. So the exact opposite the properties of metals, properties of non-metals are the exact opposite of that of metals. Okay. Now let's see some exceptions. These exceptions are very important. Okay. Let's see some exceptions. I'll be writing some exceptions. Okay. These are some important points to be noted down. Tungsten is the hardest metal. I already told you that metals are hard in nature. But cesium is an exception, lead is an exception. Cesium is the softest metal. It's the softest metal. Lead is also a soft metal. It's also a soft metal. Mercury is the only non-liquid metal. Metals are usually solids at room temperature, but mercury is the only non-liquid metal. Mercury is the only non-liquid metal, and bromine is the only non-liquid non-metal. Bromine falls into the category of the halogen group, and bromine is the only liquid non-metal known so far. It is the only liquid non-metal. So mercury is the only liquid metal, is the non-only liquid metal, and bromine is the liquid non-metal. Okay, next, hydrogen. Hydrogen falls in the category of group 1, which falls in the category of the alkali metals. Hydrogen is actually a non-metal, but it can form positive ions or cations. But it's actually a non-metal. Hydrogen is actually a non-metal, but it's categorized into the metal group. It's the first element in the periodic table, and hydrogen can form positive ions or cations. Usually non-metals are forming anions, right? But hydrogen is a non-metal, but it can form cations, H plus ions. Okay. Next, lead and mercury are poor conductors of heat. Usually metals are good conductors of heat and electricity, but lead and mercury are poor conductors of heat and electricity. They are poor conductors of heat, and usually metals have high melting point and boiling point, but cesium and gallium, they have low melting point. They have low melting point. Cesium and gallium have low melting point. They are bad conductors of heat. Cesium and gallium have low melting point. And usually the metals have high density, but alkali metals are less dense in nature. Okay. Iodine is a non-metal, but it has got a shining surface. It is lustrous. Iodine is a non-metal, but it is lustrous. And graphite and diamond are the allotropes of carbon. Carbon is a non-metal, but graphite conducts electricity and diamond conducts heat, and it have high melting point. Carbon is a non-metal. Carbon is a non-metal, and graphite and diamond are the allotropes of carbon, but diamond conducts heat and it have very high melting point. Similarly, graphite, which is the allotrope of carbon, carbon is a non-metal, graphite conducts electricity. These all are the exception. Tungsten is the hardest metal. Which is the hardest metal? A question can come, right? Tungsten is the hardest metal. Cesium is a soft metal. Cesium is the softest metal. And lead is a soft metal. Mercury is a liquid metal. Bromine is a liquid non-metal. And hydrogen is a non-metal, but it can form cations, positive ions. So it falls into the category of alkali metals. Okay? And lead and mercury are bad conductors of heat. They both are metals, but they are bad conductors of heat. Cesium and gallium have low melting point. They both are metals, but they have low melting point. Similarly, graphite and diamond, which are allotropes of carbon. Carbon is a non-metal, and graphite conduct electricity and diamond conduct heat, and which have a high melting point. And iodine is a non-metal which have got a shining surface, which has got a shining surface, and alkali metals are less dense in nature. Usually the metals have high density, but alkali metals are less dense in nature. These are the exceptions. Okay, these are the exceptions. Next, let's see. Okay, I already told you that 118 elements are discovered in a periodic table. Out of this 118 elements, 90 are metals, the rest are non-metals. Okay, so I'll give examples of non-metals. What are non-metals? Okay. Hydrogen, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. They all are non-metals. Hydrogen, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, bromine, iodine. They all are non-metals. Then what are metalloids? Metalloids are elements. They show both the properties of metals and non-metals. Metalloids are elements. They show both the properties of metals and non-metals. The examples of metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, bismuth, polonium and astatine. Okay, they are metalloids. Boron, silicon, germanium, arsenic, antimony, tellurium, bismuth, polonium, astatine. They are metalloids. They show both the properties of metals and non-metals. Actually, the rest are metals. The rest are actually metals in the periodic table. Okay. Next, let's see the reactivity series of the metals. This is all about a brief introduction about metals, non-metals, their physical properties, exceptions. Next, let's see the chemical reactivity of these metals. After that, we'll move to the chemical properties of the metals. Okay. Let's see the chemical reactivity of the metals. The most reactive metal is potassium. Potassium, barium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. Okay, potassium, barium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. Okay, this is the reactivity series. We need to by heart this series because they are very important in case of if we are dealing with the chemical properties of the metals, especially this in displacement reactions. Okay, so this is the reactivity order of the metals. Reactivity order of the metals. So potassium is the highest reactive metal, whereas platinum is the least reactive metal. So this is the reactivity order: potassium, barium, calcium, sodium, magnesium, aluminium, zinc, iron, nickel, tin, lead, hydrogen, copper, mercury, silver, gold, platinum. This is the reactivity series. Whereas potassium is the highest reactive metal and platinum is the least reactive metal. This is the reactivity series of metals. Have to note down. Okay. So let me show you the periodic table. And the group 1 elements are called alkali metals. Group 2 are alkaline earth metals. From scandium to zinc in period 4 and zirconium to cadmium in period 5, hafnium to mercury in period 6 and rutherfordium to copernicium in period 7. They are transition metals. And from yttrium to lutetium and lanthanum to lawrencium. They belong to the lanthanide series and actinide series. Okay, they are a separate category. And this actinide series, these elements are radioactive in nature. And we have 13th group is known as boron group, 14th group is known as carbon group, 15th group is known as nitrogen group, 16th group is known as oxygen group, and 17th group belongs to the halogen group, and 18th group belongs to the noble gases. Noble gases are non-metals, but they belong to a separate category because they are usually inactive in nature. They are inert in nature because their outermost shell, almost all the atoms in their outermost shell contains the maximum number of electrons. So they are least reactive in nature. They are inert in nature. actually noble gases, the group 18 elements are non-metals, but they are least reactive. They are not at all reactive, not least reactive, they are not at all reactive, they are inert in nature, they are stable in nature. Okay. So among the halogen groups, fluorine, chlorine, bromine, iodine, they are non-metals. They show the properties of non-metals. But astatine, they belongs to the halogen group. They shows both the properties of metals and non-metals. So they fall into the astatine falls into the category of metalloids. Okay. Next, move on to the chemical properties of metals and non-metals. Chemical properties of metals and non-metals. Displacement reaction. The first chemical properties of the metals. What are displacement reactions? In displacement reaction, a more reactive element displaces a least reactive element from its salt solution. Let's see the examples of displacement reaction. Displacement reactions, a more reactive element from the reactivity series. I already told you now. From that reactivity series, it is the order actually. A more reactive element displaces a least reactive element from its salt solution. Example, zinc plus CuSO4 gives ZnSO4 plus Cu. That is, zinc when reacts with copper sulfate solution gives zinc sulfate solution plus copper. Copper that we will be getting. Next, aluminium plus Fe2O3 gives Al2O3 plus iron to balance, right? 2 aluminum. Okay. Aluminium plus Fe2O3 that reacts to give Al2O3 plus 2Fe. Okay. Aluminium plus Fe2O3 gives Al2O3 plus 2Fe. Okay, that's it. Next, metals. This is all about the displacement reaction. Aluminium, Al plus Fe2O3 gives Al2O3 plus 2Fe. Next, metal reacts with oxygen. Metal plus oxygen gives metal oxide, which are basic in nature. They are basic in nature. Okay. For an example, sodium and potassium react vigorously with the air. Okay, so they are kept in kerosene. Sodium and potassium, they are highly reactive in nature. They react vigorously with oxygen, so they are kept in kerosene. 4K plus O2 giving 2K2O. Potassium when reacts with oxygen to give metal oxides, and they are basic in nature. Magnesium, aluminum, zinc and lead, they react slowly with air. They actually react slowly with air. They form a protective layer that prevents corrosion. So 2Mg plus O2 giving Mg2O, 2MgO and 4Al plus 3O2 giving 2Al2O3. Okay, and gold, platinum, silver, they usually don't react with air. So 2 magnesium plus oxygen gives 2 MgO, magnesium oxide, and 4Al plus 3O2 giving 2Al2O3, aluminium oxide. Okay. Magnesium reacts with oxygen to give magnesium oxide, basic in nature. Aluminium reacts with oxygen to give aluminium oxide, which is also basic in nature. So Na2O is an oxide of sodium plus water, which gives 2NaOH. NaOH is a base, sodium hydroxide. So sodium oxide when reacts with the water to give sodium hydroxide, which is a base. So oxide of the metal. Similarly, K2O, potassium oxide, when reacts with water to gives 2KOH, potassium hydroxide, which is also a base. So this metal oxides when dissolves in water to give bases. Next, we'll move on to an important definition, that is amphoteric oxides. Amphoteric oxides are the oxides of the metal which reacts with acids and bases to form salt and water. Amphoteric oxides are oxides of metal which reacts with both acids and bases to give product salt and water. Let's see the examples of amphoteric oxides. Let's see the examples of amphoteric oxides. Al2O3 plus 6HCl gives 2AlCl3 plus 3H2O. Similarly, Al2O3 plus 2NaOH gives 2NaAlO3 plus H2O. So Al2O3 aluminum oxide when reacts with 6 molecules of HCl gives 2AlCl3 aluminum chloride plus water. Amphoteric oxides are oxides of metal which reacts with both acids and bases to form salt and water. Al2O3 aluminum oxide will reacts with 2 molecules of NaOH base to give 2NaAlO2 sodium aluminate. It's a salt plus water. Okay. Al2O3 aluminum oxide when reacts with 2 molecules of base NaOH gives sodium aluminate. 2 molecules of sodium aluminate, 2NaAlO2 plus H2O water. These are amphoteric oxides. Okay. Similarly, PbO, ZnO, SnO. That is oxides of lead, zinc, tin. They all are amphoteric in nature. Amphoteric oxides. Other than Al2O3, PbO, ZnO, SnO, they all are amphoteric oxides. Next, we'll see the reaction of metals with water. Reaction of metals with water. Metals when reacts with water to give metal oxide or metal hydroxide plus hydrogen gas. Metal oxide plus H2O, hydrogen gas. Okay, for example, 2Na plus H2O gives 2NaOH plus H2, some amount of heat is also liberated. So, metals when reacts with water to form metal oxides or metal hydroxides and hydrogen gas is the byproduct. So, 2 molecules of sodium reacts with water to give NaOH, sodium hydroxide plus hydrogen gas, and some amount of heat is also liberated. Similarly, calcium plus hydrogen gives CaOH twice. Calcium hydroxide is obtained, and magnesium plus water gives magnesium hydroxide, MgOH twice plus hydrogen gas is obtained. Similarly, aluminum when reacts with water to give aluminum oxide, Al2O3, and zinc when reacts with water to give zinc oxide. And the reactivity of the metals with water. Let's see the reactivity of the metals with water. Okay. Sodium, potassium, lithium, calcium. They react with cold water. And magnesium, aluminium, zinc, iron. They react with steel. And tin, lead, copper, silver, gold, platinum. They don't react with water. This is the reactivity of the metals with water. Potassium, sodium, lithium, calcium, they react with cold water. Whereas magnesium, aluminium, zinc, iron, they react with steam. And tin, lead, copper, silver, gold, platinum, they don't react with water. Okay. Next, let's see the reaction of metals with acids. Metals when react with acids to give, they actually replaces the hydrogen from acids and produce metal salts and hydrogen gas. Metals when reacts with acids to give, they actually replaces the hydrogen from the acids to give metal salts, and the byproduct is hydrogen gas. For an example, 2Na plus HCl gives 2NaCl plus H2. 2Na plus 2HCl gives 2NaCl plus H2. Metals when reacts with acids, and this metals replaces the hydrogen from the acid and gives metal salts plus hydrogen gas, NaCl. Sodium reacts with hydrochloric acid to give sodium chloride. Hydrochloric acid to gives 2 molecules of sodium chloride plus hydrogen gas. H2 is the byproduct. Okay, next, metals with other metal salt solution. Metals with other metal salt solution. Metals with other metal salt solution. Fe plus CuSO4 gives copper sulfate solution gives FeSO4 plus C. Okay, metals with other metal salt solutions. Okay, the Fe plus copper sulfate, iron plus copper sulfate solution gives iron sulfate FeSO4 plus Cu. Okay, is getting the FeSO4 plus Cu. Ferrous sulfate solution. And metals when reacts with base to give salt and hydrogen gas. Similarly, metals when reacts with acids to give salt and hydrogen gas. Similarly, metals reacts with base to give salt and hydrogen gas. 2NaOH, 2 molecules of 2NaOH, this is sodium hydroxide plus zinc. Metal gives Na2ZnO2 plus H2. Sodium zincate. 2 molecules of sodium hydroxide when reacts with zinc to give Na2ZnO2, sodium zincate plus hydrogen gas is the byproduct. Hydrogen gas is the byproduct. That's all about the chemical properties of the metals. Next, when are these ionic compounds formed? When a metal reacts with the non-metals, an ionic compound is formed. Metals lose their electrons, whereas non-metals accepts their electrons. So, the bond formed between a metal and non-metal is an ionic bond, and usually metals and non-metals form ionic compounds. Let's see, calcium is a metal, okay? Chlorine is a non-metal. The configuration of calcium is 2882. Ca2 plus calcium ion having configuration 288. It loses its outermost 2 electrons, and the configuration of chlorine is 287, and Cl minus when accepts 1 electrons, 288 will be the configuration. So the calcium loses its 2 electrons to form Ca2 plus ion, whereas chlorine accepts 1 electron. One chlorine atom accepts 1 electron to form a stable configuration 288. So the calcium chloride CaCl2 molecule, which is an ionic compound, and the bond formed between calcium and chlorine here is ionic bond. Calcium chloride CaCl2 is an ionic compound. Calcium is a metal and chlorine is a non-metal. So they are forming a bond, ionic bond, by donating electrons and donating and accepting electrons, and an ionic compound. When a metal react with a non-metal, an ionic compound results. Actually, 2 molecules of chlorine, 2 atoms of chlorine are reacting with calcium atom to form a CaCl2 molecule, which is an ionic, not molecule, CaCl2 compound, which is an ionic compound. And the bond formed between calcium and this chlorine atom is ionic bond. Okay. So the one chlorine atom can accept 1 electron. Calcium donates 2 electrons to form Ca2 plus ion. So when Ca2 plus, as when calcium reacts with 2 atoms of chlorine, CaCl2 is formed. Calcium can lose 2 electrons and 2 chlorine atom accepts these 2 electrons. So CaCl2 compound is formed. It's an ionic compound. And the bond formed between calcium and chlorine is ionic bond. Okay. Next, let's see what are the properties of these ionic compounds. The ionic compounds are crystalline in nature. They have high melting and boiling point. They conduct electricity. They don't conduct electricity in a solid form. They conduct electricity in their aqueous form. Okay, they conduct electricity. They are soluble in water and they form polar solvents. They are actually, the bond, ionic bond is polar in nature. No? They are hard solids, but when pressure is applied, they can be broken. Okay, and they have, the ionic solids have a definite crystal structure. They have a definite crystal structure. So ionic compounds, the main important point is ionic compounds don't conduct electricity in their solid state. They conduct electricity only in their aqueous state. That is, they have free ions out there, so they can conduct electricity. So the other examples of ionic compounds are NaCl, a sodium metal, and chlorine non-metal, K2SO4. K2SO4, NaCl, CaCl2. They all are examples of ionic compounds. They all are examples of ionic compounds. So that's all about metals and non-metals. I think I gave a brief description, not much, but a brief description about metals, non-metals, their physical properties, exceptions, their chemical properties, what are metalloids, what are ionic compounds, the reactivity series, displacement reaction, metals reacts with reaction with the oxygen, water, metal with the non-metal, and amphoteric oxides. Amphoteric oxides are oxides of metals which reacts with both acids and bases to give salt and water. Amphoteric oxides, and reaction of metal with water, and reaction of metal with acids, and so on. So okay, so we'll discuss about a new topic in another video. Thank you so much. Hope you all understand. If you have any doubt, you can message me. Thank you.